Hey everybody, Mr. Murray here on Mr. Murray's Mathland, and today we are looking at graphing lines, and you're going to learn a lot of different ways to draw graphs, but one way is to do it by making a table, and this is actually a basic technique for drawing a graph of any equation. When you're not sure what you're dealing with, you make a table and you plot points. So this is actually the first way we're going to learn, even though we will learn some faster methods that are more specific to lines. So what we have right now is this equation, y equals negative 3x plus 4. So the y value is isolated, and it will be negative 3 times whatever x value we happen to plug in, and then plus 4. So what I'm going to do is make a table here. It's called an XY table. Some people call this a T-chart, x and y. And keep in mind that y is equal to negative 3x plus 4, just using this equation. So I can plug in any x values I want. A great one to plug in is 0. 0 is an easy number to plug in. 1 is another one that's pretty easy to plug in. And you really only need 2 points to plot a line, but I usually like to use 3, at least 3, just to make sure you haven't made a silly mistake. So whatever x value you happen to be choosing, your y value is going to be negative 3 times whatever x plus 4. So here's the deal, negative 3, and I'm going to use parentheses because where x is, I'm going to plug in my x value. And that's really what I'm going to do for each one of these. So when x is 0, I'm going to plug in 0 here. When x is 1, I'm going to plug 1 in here, and when x is 2, I'm going to plug 2 in here and see what I get out for y. Now you can do this using your calculator. You can do it in your head. You can take steps and do it, but it's pretty easy to do in your head here. Negative 3 times 0. Now order of operations, we multiply first. Negative 3 times 0 is 0. 0 plus 4 is 4. And that means I plugged in 0 for x and I got out 4 for y, right? That was my x and that was the y I got out. Now when x is 1, negative 3 times 1 is negative 3, and negative 3 plus 4, negative 3 plus 4 is 1. So I plugged in 1 for x and I got out 1 for y. When x is 2, negative 3 times 2 is negative 6, and negative 6 plus 4. And again, if you have trouble doing that in your head, then write it out. Negative 6 plus 4, and that's negative 2. So I plugged in 2 for x, and I got out negative 2 for y. And now we're going to plot these points, and just be careful doing so. Remember, your x-axis is the horizontal one. So 0, 4 means, don't go right or left at all, but go 4 units straight up. There's the point 0, 4. 1 comma 1 means go 1 to the right and up 1, and 2 negative 2 means 2 to the right and down 2. And now you just connect, notice they're all right in a line, those 3 points. So you just do your best using a ruler or the edge of your notebook or some sort of straight edge to help you draw a straight line through these. And there we go. Pretty easy, right? Okay, so let's just try a couple other examples here. Here's another equation where y is isolated, and that's really when making a table is a good technique, when the y value is all by itself. So I'm going to make my table here, and y is going to be 1/2 of whatever x value I choose, and then plus 3. So notice there's a fraction in this one. So I'm going to still plug in 0 for x. That's pretty easy to work with, right? So if I plug in 0 for x into the equation, 1/2 times 0 is 0, and 0 plus 3 is 3. So that means I'm dealing with the point 0, 3. However, if you plug in 1, usually I go 0, 1, and 2. If you plug in 1, notice what's going to happen here. And this isn't terrible, but notice why it can be a little annoying. because now you're going to have fractions. You'll have 1/2 times 1, which is 1/2 plus 3. And so you'll get 3.5 or 3.5. And plotting that, 1 was my x value and 3.5 or 3.5 was my y value. It's hard to plot it with a great deal of accuracy when you have a fraction. So a lot of times I might look ahead and say, look, whatever value I plug in for x, I'm going to have to take half of it as my first step, right? I'm going to multiply by 1/2. So why don't I choose numbers that are divisible by 2? For example, 2 would be a great number for x, because as soon as you plug in 2 for x, 1/2 of 2 is 1, and 1 plus 3 is 4. And so I got out whole numbers there. So I plugged in 2, I got out 4. And if you wanted to think, okay, what's the next like nice number I could plug in? You could skip over 3 and you could plug in 4, any even number. So in this case, if you plug in 4 for x, 1/2 of 4 is 2, and 2 plus that 3 is 5. So I plugged in 4 and I got out 5. So that's up to you, really. If you want to try to avoid getting fractional y values, pay attention to whatever fraction there is right there, and put in things that are divisible by that denominator. So here are my points, 0, 3. So we are right on the y-axis at 0, 3. And 2, 4 was the next nice one I got. 4, 5. And you see how that 1, 3.5, that point right there, it would be like right there, right in line with the others. But again, if you like to avoid the fractions, then that's something you can do to make that happen. Okay, I'm just going to straighten that out a little bit. And there we go. There's our line. Beautiful. Looking good, right? Okay, so now we've seen one with some fractions in there and how to handle that. And now here's another example which sometimes throws people off, but it's actually even easier, is when there's only one variable, y equals -3. Well, in this case, if you think about it, it's saying y equals -3. It's kind of telling you it doesn't matter what x is, 0, 1, 2, y is going to be -3 no matter what x is. It's like saying I don't even care what x is. Y is -3. Bam. And so when you plot those points, 0, -3, 0, -3, 1, -3, 2, -3, or anything with -3, when the y value is not changing, you see what we get? We get a horizontal line. And this is something you'll start to just recognize, that whenever you have just y in the equation, that will always end up being a horizontal line. And a little mnemonic for this we'll talk about is called Hoy-Vux. Hoy-Vux, and Hoy, part of it is a horizontal line always has a 0 slope. That's actually a 0, not an O. And just has y in the equation. So if you just have y, you're a horizontal line with a 0 slope, even though we'll talk about slope on another time. And you're going to see the Vux part stands for a vertical line has an undefined slope and just has x in the equation. It's kind of the opposite. So x only, y only. Okay, last problem here. And this is kind of the flip side of the one we just did, that what if there's only x in the equation? And if you caught the Hoy-Vux that we just talked about here, if you do it by making a table, this is saying x is 2. X is 2. So it's saying really x can't be anything else. X can't be 0, 1, or 3, or anything else. X has to be just 2, 2, 2. But y could be anything. That's kind of the opposite. Y could be 0, 1, or 2, or whatever. So now you've got, just points where the x coordinate's not changing. And when you plot these, maybe you've already started to guess what this is going to be. 2, 0, 2, 1, 2, 2. Anytime the x value is not changing, you're going to get a vertical line, and that's the other part of Hoivux, the little phrase you're going to hear me say a lot. A vertical line has an undefined slope and only has x in the equation. So there we go. Saw 4 examples, a couple of each kind. Hopefully you're feeling good with this stuff. It's really not too bad. Just take your time with the order of operations and plotting your points carefully. So if you have any trouble, just let me know. Good luck, kids. Keep working hard.